Hi students, welcome to the Chem 300 series and Properties and Structures of Matter video number 20 on the oxides and the periodic table. In this particular video I'm going to have a look at a couple more of the trends in reactions, particularly more starting to get some practice at writing equations, and this is obviously something that's going to be critical to your study of chemistry. Not all of the reactions that you might see on these videos we may be able to carry out in class. It's going to be a little bit time dependent, but we'll have a quick look at them anyway, and they'll be a reasonable introduction for later on when we study some of these in a little bit more detail. So metal plus oxygen, one of the simplest and certainly most impressive reactions is the reaction between magnesium and oxygen. And when these two are reacted together, you get a very bright light. One we ask you not to look at because it can do a little bit of damage to your eyes when you do. When we write the equation for this, solid magnesium combines with oxygen, which is diatomic, so we write it as O2, and it forms magnesium oxide. Now this is a white solid. A lot of it actually disappears as smoke when the process is occurring. This equation is not balanced, so I will just need to put a 2 in front of there to balance up those two, but then I'll also need a 2 in front of my magnesium, and now my equation is balanced. So this is a substance that we get from the burning of a metal. But what happens if we burn a non-metal in the presence of oxygen? Well, one example, there's a few that you can do, hopefully in a fume cupboard, and we'll have a look at this particular one with the deflagrating spoon and gas jars in the fume cupboard. And that is sulfur in combination with oxygen, and this forms a gas, sulfur dioxide. This one is already nicely balanced for us, so that makes life a little bit easier. This is a very dangerous gas. In fact, it's one of the gases that contributes significantly to acid rain, and something that we will have a look at a little bit later on. Both of these two substances, the metal and the non-metal, are forming oxides, but the nature of these two oxides is quite different, and again something that we want to explore a little bit in class. For now, just a quick look at the reactions to kind of, I guess, maybe spoil the surprise a little bit, but to see if you can actually confirm these when you're working through them. Hopefully by the time you have a look at this video, we'll have already had a chance to explore some of these, but if we haven't, at least you've got a little bit of an idea what's coming. So our metallic oxide was magnesium oxide. It's a solid. What happens when we put that into water is we produce magnesium oxide, hydroxide, I should say, MgOH2. Nicely, this one is also balanced. It's aqueous. One of the things that we notice is in the presence of a universal indicator, this would indicate a basic solution. And one of the things that we do is we classify metal oxides as basic oxides, and that's primarily because they are going to produce basic solutions. Okay, so it's usually going to be a purple color, and it's going to have a pH that's greater than 7 pH. Conversely, our non-metal oxide, our sulfur dioxide, if we bubble that into water, or perhaps more safely if we do that with carbon dioxide, what we produce is, in this case, H2SO3, which is sulfurous acid. Okay. This is, if the clue hasn't been given away now, going to, in the presence of universal indicator, indicate an acid. It's going to be a reddish color, and it's going to have a pH much lower than 7. And so non-metallic oxides are called acidic oxides, and you might remember that I mentioned that these can be contributors to acid rain. Now, one other little reaction that you may want to have a look at is the reactions between elements and dilute acids. So if we were to put, say, magnesium into a dilute solution of hydrochloric acid, what might we expect to happen? Likewise, if we were to put something like carbon or sulfur into some hydrochloric acid, what do you think would happen? Perhaps you might be able to carry this one out in your laboratory and find out. Thanks for watching.